Hello, everyone. Thanks for joining us today as we come together to learn more about continuous delivery for machine learning projects with Azure pipelines. My name is Hussam. I'm the program manager for Microsoft Reactor in Abu Dhabi. Microsoft Reactors are hubs for founders and developers to meet, learn, and connect to local peers, as well as industry-leading ideas in technology from Microsoft, their partners, and the open source community. It's also home to the Microsoft for Startups program, with a diverse mix of hands-on workshops, expert panels, and community events. There is something for everyone. Check out our calendar of events on meetup.com and join our upcoming sessions. Our speaker today is Sherif and Mahdi. Sherif is a senior industry software development engineer at Microsoft. He's part of Microsoft Commercial Software Engineering and works with top global enterprise customers with main tech focus on DevOps and AI. Feel free to ask questions during the session. We will have regular stops to answer these questions, and also feel free to tweet about the session and tag us on Reactor Abu Dhabi. That's the name of the hashtag, and our Twitter handle is MSFT Reactor. With all that said, I hand over the mic to our speaker to start the session.
Perfect. So thank you, Hassan, for the introduction. As mentioned, I am part of the commercial software engineering team at Microsoft. So mainly I lead the projects of focused DevOps and AI that we co-engineer with our top enterprise customers in that area, mainly in the retail area. And today we will be talking about how to build the DevOps pipeline, like end-to-end DevOps pipeline to for your custom machine learning modeling projects to accelerate to have a continuous delivery and accelerate your go-to-market of your ML projects, which is really growing big time, and we have been working with a lot of companies on building and constructing this DevOps pipeline to make sure that we have the right infrastructure and the right pipelines for data science teams to be able to develop more AI-based projects and accelerate the GTM of these projects. I mean the go-to-market. So the agenda of today is mainly tailored around DevOps and ML, as you know, and we will start with a knowledge refresher for DevOps just to get our mind into the DevOps practices and habits and the culture of the DevOps in general, and then we move the focus a little bit to get introduced to the Azure Machine Learning Service, which is one of the major services that we will rely on throughout our walkthrough, and then we will have a demo or a walkthrough showing the model deployment, how we do the deployment, just to have an idea on the MLOps part, followed by our first checkpoints for the Q&A. So mainly we will have 3 checkpoints for the Q&A during the sessions, just to make sure that we are engaging on a regular basis during the session to get the questions answered as we go. And then we will move the focus to our project overview. So today we'll be walking through an end-to-end project on Azure DevOps, and we will cover during a comprehensive list of the DevOps practices to specific projects. Mainly it's an ML classification project. So we'll have 2 parts for this walkthrough. The first part will be focused more on the planning part, the backlog, and we will stop before the release definition, and then we'll have our second checkpoint followed by the last part of our end-to-end scenario, focusing mainly on the release and the monitoring, and then we'll have the Q&A and the final open discussion. So to get started from this, mainly DevOps, it's a lot of people I work with when we started like 3 years ago, they have this perception that it's just about product and tools and making sure that we have a process in place. But in fact, it's different than this. DevOps, it's mainly around the people, the process, and the products to enable the continuous delivery of your project. So it got a lot of phases. They are mainly 6 phases. We start with the plan and track, and that includes things like building your backlog, having your work items organized. So it's kind of having the right plan and the right capability of tracking your progress as a team or as a development team in this phase. And then the other one is the development, which includes practices like continuous integration and having your development team or your data science committing the code, doing the code reviews. So all of this happens under the second phase, which is the develop, and definitely build and test, which include automated builds, automated tests, and making sure that your solution is building in the right way. And if we are in the right track, we deploy to different environments. So this is the fourth stage where we got the deployment part, and that's where you focus more on the release definitions. So in this phase, that's where you have different environments, like in dev and test environment, where you deploy to on a daily basis, staging, Q&A, and production. And we have a happy path, all good from dev and ops perspective. We get into operations by releasing into production, and then we move to the last phase, which is monitoring and learn. And you get to the same loop again, because when you monitor, you discover areas of improvement. So you have to go back and to your planning, update your backlog, and go through the end-to-end life cycle again. So from this part, if we have a closer look on the DevOps practice, so that's a really good definition, but it's kind of generic. But when you look at it, so to have a closer look on what actually you should be doing, there are a lot of practices at each stage. So for example, for the flow of the customer value and making sure that we are releasing and having a good, efficient, continuous delivery, you got automated testing, continuous integration, continuous deployment, and release management. So these are some of the practices that we will actually cover today. But for the nature of the projects that falls under custom machine learning modeling, also there are some practices that rely on the scaling of your product, so you can consider like automatic scaling. So there are a lot of practices, and each practice falls under one of the categories that rely under one of the 6 essential pillars of the DevOps. And during the session, we will have focus on the most important practices that we will use to implement a continuous delivery pipeline for machine learning projects. But one of the most important thing that I always like to highlight, and I always tell this to all the teams I work with when we start building DevOps pipeline, it's all about making sure that we focus on the DevOps culture and have the right implementation of the practice that we are implementing, not just the tooling, because again, it's all about the having the right DevOps concepts in place. So tools, you have a bunch of tools that serves all the practices, and to select the tools, there are different factors that you need to consider. So for example, one of the factors is the skill set of your team members. Maybe another factor is how comfortable the other teams working with your team in terms of having different stakeholders for your project are with this tool. So the main focus is the culture and making sure that we are implementing all the concepts and the practices that serves our DevOps target, which is the continuous delivery. And tooling, there are bunch of tools that can serve this purpose. So in this demo, I will be mainly using some of the tools, but this is not all of it. You can change the tooling, you can pick your own tool that suits the teams and serves the main purpose for the practice that you are implementing. From this point, we will move the focus a little bit under the same idea of having a knowledge refresher, just to understand what is Azure Machine Learning Service, because in my project, I will be relying on this service big time to implement the CD pipeline. So Azure Machine Learning Service, it's just cloud-based environment that you can use to train, deploy, automate, and manage your ML models. So it's environment that allows you to manage the end-to-end machine learning model workflow, starting from preparing your data, running the machine learning training, do the evaluation, packaging the model, taking this to the further step by deploying your machine learning model, and then monitoring the performance of the model, then retraining again and have the same loop. And the good thing about this service is that you can use it with different or any kind of ML projects, from classical ML to deep learning, whether it's supervised learning or unsupervised learning. And finally, we released our support for R, so now you can use it with Python and R. Personally, I worked with a lot of teams, and there's a very interesting mix between people who focus on Python to run their ML models and people who utilize R to do the end-to-end cycle of the custom machine learning modeling. So the service is flexible here and can serve both of purposes. And one of the first questions that pop in your mind when you learn about any new service is how I'm going to use the service. So we got different ways of doing this. The first one is the programmatic approach. So we have an SDK for using the ML service, whether in Python or R. And there are some no-code tools that you can rely on as well, which is the Azure ML Designer and the automated ML UI. In our walkthrough, we'll mainly be focusing on the programmatic approach. So we will get into code, see how to use the SDK, how to run experiments using the SDK, how to deploy the model using the SDK, how to do the evaluation, how to register the model when you reach the optimal performance that you are happy about. So today we'll be using the SDK, and in a specific we'll be using more the Python one. And one of the other questions that a lot of the companies I work with, they ask in the first meeting, okay, so what would be the compute target if I used my Azure Machine Learning Service? Can I train on my local computer? Can I do this on a remote VM? What if I'm considering Databricks? And this is a very, very valid question. And the answer here is that you can actually use all of this. So there are a list of supported compute targets that includes your local computer, the ML compute cluster, the remote VM, the Databricks. You can use Azure Batch, HD Insight, Data Lake. So all of this could be options, but you need to check this link because from pipeline perspective, you need to know the differences from what's supported and what's not supported in the compute target when you're setting your training targets. And another question that we realized it's one of the first things that people ask when we introduce the service in any of the projects that we consider is, what if I don't want to use the ML service for the end-to-end life cycle? So for example, the end-to-end life cycle includes data preparation, training and evaluation that falls under the experimentation part, and the model deployment. Can I use it for a specific purpose only, like for example, the deployment, or if I'm using the service, I have to do the end-to-end custom ML life cycle? So the answer here is yes, you can use it for just a specific purpose. So for example, you can use the Azure ML service for just deploying your ML model. So you do the training, starting from the data preparation, the training, the evaluation, all of this, not using any of these services. You are doing it your own, and then you decide just to use the Azure ML service to deploy your packaged models. And to do this, you need to have a couple of steps that we will show during the walkthrough we are having now. But it starts mainly with creating a scoring file for your ML model, which is simply a file that you load the model, you give it the input, you do the scoring, and you get the result, which is an example that you pass to the service so that you can be able to deploy the model as a real-time service, as an example. And then the other part is, since we are using Azure Kubernetes Service or ACI as part of the compute targets we will discuss later, or we will show later when we talk about the compute targets of the deployment, you need to create and configure a Docker image. And we will see how to do this through the hands-on experience that we will have during today's session. But this is a simple Docker image that you create that allows your model or contains the right configuration needed for the environment to run your model and be able to do the scoring. And since we are using the Azure ML service here, we need also to use another part of another resource here called Azure Container Registry, which is simply you can look at it as container for Docker images or storage for Docker images. So that's where you store the image of your Docker container, and as a follow for this, you register the model to the Azure Machine Learning Workspace, and then you rely on the SDK just to deploy this image and deploy the model as a web service in the cloud, followed definitely by the monitoring part and the data collection. So this is as an example for how to use the ML service for just model deployment, and we will see this in action when we start the focus on the walkthrough and walk through the current project that I have developed to walk you through all the concepts and the DevOps practice for the ML projects throughout the session. So for the deployment, regarding the compute targets, we saw different compute targets, but I was mainly talking about the training part. This is the list for the compute targets for the deployment part, not the training part. So you can host the web service that represents your model. If you are deploying as a real-time web service on your local machine, you can use the Azure ML compute instance web service. You can use Azure Kubernetes service, and this is one of the most used services. So out of all the projects we developed for ML DevOps with most of our customers, AKS was the decision when it comes to the production, and people mainly rely on ACI for dev and test. So AKS is really good when it comes to high scale production deployments. To reflect and be kind of an expose an interface for your users to use the model. And when I say users here, I don't mean end consumers. It could be internal users that are consuming your machine learning model within your company, or even another community that you are exposing this model to. So there are a bunch of available deployment compute targets that you can rely on. In our project, we will be using mainly two things: the Azure Kubernetes service and the Azure Container Instance as an example. As just to give an idea of what technologies are provisioned when I just use the Azure ML service for deployment. First of all, since you're using the Azure ML service, the first thing you need to do is to provision Azure Machine Learning Service workspace, and we will see this when we start as a first step. And since we are using it for deployment, and we're relying on Docker images, so we need Azure Container Registry to store the Docker image, and also the ACI resource itself, in addition to a storage account that can have a blob to do the monitoring and collect the data that you need to monitor, and definitely use the Azure ML Service SDK for Python. So this is just for an example on what are the resources provisioned in terms of key technologies when I pick Azure ML Service just for the deployment purpose. And it's really good to know this because it helps big time in the cost exercise or the sizing exercise, or when you work with your infrastructure team and you want to know and you want to submit and request just to have these resources provisioned. So this is the essential key technologies that are provisioned when you say, okay, I'm using this for ML deployment. And by that, I think we reached the end of the knowledge refresher. So this is kind of the slides I have. We'll be moving more into the real work and the walkthrough. So we open Azure DevOps, walk through the end-to-end project, starting from the building the backlog, having the data, doing the data validation, how we set up the environment, how we run the training, taking this further from CI, CD, monitoring, and releasing to different environments. So let me have my first stop since we reached the end of the knowledge refresher, just to check if we have questions, and then we can start the right demo. So please feel free to publish any questions you have. Cool. So it seems like all clear so far. Let me move to the demo. So before moving to this, let me just show a quick visualization of our practice. So we will be building together a continuous delivery pipeline. So these are the practices that we'll be showing throughout the project. So we'll have a brief on how to build the backlog, another one on showing the data I have prepared just for the walkthrough and how I'm validating this data, followed by the environment setup in terms of having the prerequisites like libraries, packages needed to have the environment up and running for the ML, and also we'll focus on the ML training. So the problem we are focusing on here is mainly classification problem, and it's text classification, so no GPU is required. We will highlight also some practice for the CI, followed by build definition, release definition for a dev and test and production, and we will highlight the key vault and the monitoring at the end. So let me move to Azure DevOps. Perfect. So in this project, I have the end-to-end pipelines. I just want to give an idea of the backlog. And the backlog here, it's kind of mix and match. So we have different features. The first one is mainly a feature that you normally, and the user story that you normally see on daily backlog of a data scientist. So here, for example, the feature is how to build a mature text classification model using scikit-learn. And this is a feature and the user stories and tasks that you normally find in the backlog of the data science team. On the other side, there are different teams within the company or even the community that are working on making the life of these data science teams much easier. So these teams are mainly on the infrastructure side, that they are main concern is how to build an end-to-end pipeline for this data science team to use and make sure that this end-to-end pipeline allows the data science to run the training, the evaluation, the data preparation, the deployment of the model, the monitoring. So this end-to-end life cycle needs to be managed in an automated way following the right DevOps practices. So the ideal situation is that you have a team dedicated for building this infrastructure for the data scientists, and the data scientists just focus on utilizing this platform and focusing on the modeling itself. And throughout the session, our main focus will be on this part, the second part, which is how to build this DevOps pipeline and making sure that the life of the data science people are easy when it comes to modeling, experimenting, registering models, and deploying. And we will wear different hats during the session just to give an idea of what should be done under each practice and under each DevOps concept here. So let me just move to the repo. So what I used to build this backlog, it's Project Kanban on Azure DevOps, and I'm relying here on Azure repos. Definitely some people say, okay, I prefer more to use GitHub. You can still do that and connect your GitHub repo to Azure DevOps, or even if you're using different toolings like Bitbucket, for example, you can still do that and connect it to Azure DevOps. So, and that's the idea behind focusing on the DevOps culture itself, not the tooling, because the beauty about Azure DevOps, it's very compatible with a bunch of tools that you can consider, whether from Microsoft Stack technology or even open source technologies that you can connect directly to Azure DevOps and get started. So to give you an idea of my file structures, I have here some data. So this data is it's as simple as just to give an idea of a training data and testing data. It's simply records of diabetes. I loaded this from the open data set of the scikit-learn library. So it's just a CSV file that includes data showing age, sex, BMI, and different features to help the model classify whether this person is diabetic or not. So this is like the good training data that I'm using, and as also this is the testing data as well. So I do split this data into 75 for training and 25 for testing, but this is the good data. I also created some examples of bad data. So for example, this some records that have missing values from my features table. Also this other data that has having a bad schema, and this another example for data that have bad distribution. And the main reason I created these examples is that throughout my pipeline, I will rely on this data to do the testing, just to make sure that there are data validation before we run the training. So that's the part. The other part here is that since I am running this into the Azure DevOps host, it's not on my local machine. So I need to have a step in my build definition to install the right libraries. So you can see I'm using pandas, I'm using NumPy, I'm using SciPy, scikit-learn. So these are the libraries I'm using. I added it here in this file, and I have a bash script that installed these Python libraries, and definitely I add to it the Azure Machine Learning SDK that we mentioned in the introduction. So to be able to use the Azure Machine Learning Service, you need the SDK. So I'm adding here this pip install line to install and upgrade the Azure ML SDK, in addition to the other Python libraries like pandas and the rest of them mentioned in this file. So that's where I'm having just this bash script, and I will be using it into my pipeline. So normally as a data scientist, you focus on this part. You focus on writing code to train, right, and evaluate. So that's the life. You don't care about the pipelines. I don't care about how we are going to build, how we are going to release, how we are going to do the modeling. So the main focus of mainly almost all the data science are working with on how to build the right model, which is the typical job goal here. So all what's needed from the data science order not to overload them with this. As a data science, you just need to follow the source control right practices in terms of committing, cloning the repo, not to commit directly to the master, and respect the branch policy, do a pull request when you do a code review. So that's all what's needed from the data scientist. And if you recode the backlog, we have this feature that the data scientist here is required to build a classification model, and this is just an example of some Python scripts that helps the data scientist to load the data and do and as you see, we load the data from the sklearn data sets and do the training to have a model that does the classification whether this patient or diabetic or not. So just to get started before we move here to how we are going to build this pipeline, this like end-to-end pipeline in terms of automated build, we'll get to this point, but just to get an idea of what's needed here from the data scientists, just to scope on the focus, let's clone this repository on my machine. So let me say get clone and paste the link of this repo, just to get these files on my local machine so that I can edit. And the first thing you should do here before touching any of these files or doing any modifications is that you create a branch, right? So as a data scientist, you say, for example, you are modifying this file of the training, and you want to make sure that this is reflected in the central repo. So the first thing that you should do just for the changes and as a good practice is not to commit to the master. And also I will show you from the other perspective, from the infrastructure perspective, how not to allow this to happen. So let's create a branch, say, okay, create maybe updated config. Maybe I updated the configuration we are having. So this is the branch, but this will not work because we need to change the directory first to the repository. So if I can create now the branch, you see that now it's moved from the master to the branch we just created. And then let's say that I will go to this file, for example, this is the training file that I'm using. Sorry, this is the execution. I don't want to execute it. I just want to modify it. I'll be using here Visual Studio Code. And let's say, for example, I just add a normal comment here that live from session. Then I will save it. So let's say that the data scientist just added the modifications needed here, which include implementing this Python script for sure. And if we check here to add the files, we will notice that this will turn into red. If you use Git a lot, you know that that means there are some changes that happen. So I'm going to commit my changes as a data scientist. And let me say that I updated project Azure ML configuration here. But this commit is done locally, so I need to push these changes to the origin. So let me push this to Azure repo, which is done. So if we get back here to our Azure DevOps, I should be able to see here in the commits, or in the first, let's go to the branches. I will find that updated config. This is the branch we just created just now. The next step that you as a data scientist need to do here is if you finished your script in terms of Python, or even if you are relying on notebooks, is just to create a pull request. And this pull request means that I want to merge the change happening in this branch into the master branch. And a very good practice here from infrastructure perspective, not from data science perspective, is that you can come here to this master, move to the branch policy, and define your policy for the master branch. So the first thing is that it requires a minimum number of reviewers to be able to merge this. So normally these are engineering managers or data science leads or people who do the code review sessions with their team members before merging to the master and moving forward to the build step. Another good practice that we rely even internal on our projects and Microsoft is that this commit needs to be linked to a work item. And what does it mean? It means that since we have here in the backlog tasks, and in these tasks, you got people assigned to it. So when you do a commit, you have to link it to one of the work items just for a better visibility and be able to do a better job when it comes to tracking who is working on what and what comments are related to what tasks. So to create a pull request, it's as simple as that, and you can still do this by using, for example, GitHub. I'm just using Azure DevOps here because this is my comfort zone, and used a lot with the projects I'm running, but you can definitely use your own tools. So here, since the policy is mentioning that we need the minimum of 2 approvers, and we need to be linking this to a work item. So for example, I will add this work item as if it's related to my commit, and I added myself as a reviewer. It should be the case since we have the policy that you have more than one reviewer. So if you look at it here, you wouldn't be able to approve, even if you are the manager, you wouldn't be able to approve the pull request, even if the code review is perfect, you are writing the right stuff, unless you have this policy met, which is missing the 2 reviewers. And one of the good things that you can rely on here is that from the branch perspective, you shouldn't allow that people who, even if I'm the admin, I shouldn't be able to approve my own changes. So there's an option to do this, but we don't recommend it. So from data science perspective, to summarize this, what's needed is that as a data scientist, you are the user of the DevOps pipeline. So you are not expected to build the pipeline. You are just expected to run your experiments, do the Python or the R code you want, commit, do code reviews, and merge. That's it. So this is what kind of what's needed from your perspective. And definitely this is for the sake of simplification, I'm using just one data source. Normally, we have data pipelines to grab the data required for your training from different data sources. And there are a lot of technologies that you can rely on to build your data pipelines. But taking this forward, let's have a look on our pipeline. So what happens when you did this pull request and it merged successfully with your master branch? The normal step after that is that you want to build. And when you build your pipeline, you can say, okay, I want this pipeline to be triggered and by merging with the master. So as you see here, I am enabling the continuous integration and I'm filtering the branches just to focus on the master branch. So once the merge happens, and this will happen by approving the pull request, these build steps will be executed, and we will walk through step by step to see how I built this pipeline to make sure that we reach the next step by having the release successful as well. But the first thing, if you are building this scripts that you are having, is that you need to install Python on the agent. So I'm using Python here to use Python version 3.6 just to install it. And if you remember, we walked through the environment script, right, which included the installation lines in Python, like installing pandas, installing NumPy, installing the Azure ML SDK. So these are the libraries required to be able to run and be able to have the right environment setup. So this should be, I added it as the second step after installing Python itself on the agent I'm using to build my solution. And if you recall the knowledge refresher slides that we mentioned, that if you are using Azure Machine Learning Service, which is my case, the first thing I need to do is to create a workspace. So for example, this is how it looked like when you create the Azure Machine Learning Service. So this is the machine learning service on the portal, on the Azure portal. So this is the kind of the UI part of it. You can track your experiments that you are running. So for example, here just have one machine learning experiment. You can track the models you trained and you can do versioning of it. So I have two versions of the same model. Simply version 2 is better in terms of performance, precision and recall. Also, you can track your Docker images that you used and you created to go through the deployment phase. So as I mentioned, the Azure ML service provides you with an SDK, but you can have visualized view as well to track what's going on from the Azure portal. So what we are trying to do is that we build a DevOps pipeline that automates the process, and the result will be having this resources provisioned programmatically and in an automated way through the right DevOps practices. And to be able to start doing anything with the Azure ML service, you need to create what's called the workspace. So we have a script here. If we go back to our repository, it's a command line interface script using Azure CLI, Azure Command Line Interface. And this script is under this folder that relates to the ML service. And normally it's not the job of the data scientists to build these scripts like to create the workspace, scripts to create the Docker image, scripts to deploy the ACI. It's not the job. Mainly there are people within the company who are working on developing this infrastructure and developing this DevOps pipeline, so that the data scientists just focus on this part, which is the data science code, run the experiments, writing the code for the training, evaluation, and testing, and utilize directly the ready-made pipeline. So now I'm just changing or wearing different hat. I'm not a data scientist anymore. I'm the guy who are building the DevOps pipeline for the data scientists to use and be able to run the experiments and deploy their model and have the most efficient continuous delivery rate for these experiments. So it's very simple. Since I'm running this on the CLI, I'm just I'm just loading the ML SDK since I have it installed, and I'm printing the SDK version I'm using just for the demo purpose. And if you notice here, I'm loading a file called config.json. So this config.json, it's simply having my subscription ID, resource group, workspace name, and the location. You can simply have the workspace name whatever you want. You can just change it from the config.json. And then I'm just using the SDK to either get a ready-made workspace if it exists, or if it's not, I create a new workspace. So it's as simple. This is a very simple Python script just to create the Azure Machine Learning Service workspace. And this it's considered as the third step in my pipeline. So from this part, since I have the Python installed on the agent, I have the right environment setup installed on the agent, I have the workspace created. So the next step is simply to train. And as we mentioned in the knowledge refresher part on the Azure Machine Learning Service, you have a lot of compute targets that you can use to train. So here I'm relying on the local training, but you can, for example, attach a VM, a virtual machine, and train on it. So if we look at this step, it's simply calling train local.python, which is another Python file that I have here under the Azure ML service. And it's as simple as that. And that's the beauty of the SDK, that it says, okay, please retrieve my workspace using the right configuration of it, create a new experiment, and you can call it as you want, and then it refers to the training file that's created by the data scientist. So if you see here in this script, it relies on the SDK, and it says, okay, this is the script file path, which is under the data science code, and it's called train.py. By the way, I'm just hard coding it in this for the demo sake because I just have one script. You can definitely make it more dynamic, and for sure, you have, if you're working on a project and you got more than data scientists, you can have this dynamic to pick the right script that needs to be running to express my my experiment on the Azure ML service. So if we move here back to the pipeline, just to show you the other steps. So this step just run the training. And one more thing that you could consider as well is to add another step here before the training to do the data validation. If you remember, we have data that represents bad distribution, bad schema. So you can add one more step here that is an Azure CLI step as well. And these steps will just call an inline script which you have in the repository. And this script just run the data validation using unit testing or making sure that you have the right data format before training. And typical sense, you are training for better precision and recall, you need to evaluate. And by the evaluation, you need to compare your newly trained model with the previous one, just to decide whether you want to register this model. And I mean, when you register this model, is just to be able to see it here as one of the models you produced, and it got a version number, so that you can have a solid tracking of your models with versioning, descriptions, and who created this based on what experiment. So this step is just using also the SDK to register the model. So if we have a look on the repository and we jump into the Azure ML service part, you can see that we have a script also for registering the model, and it's the same as the previous scripts. It relies on the Azure ML SDK. So you can see here that it uses the Azure ML.core, and it comes to the point where it takes the model and do the registration of the model. So it's just a matter of just one function call, like model.register, and you give it the model path, you give it the model name. If you want to tag your model for better searching, if you want to write a description, and it's by default the Azure ML service give it a version. So it's a good thing that you can just rely on this SDK to have this is happening. And as you see here, my model is in a PKL format. I pickled the model, so I just had it, and you can see it here visualized and registered the more you run experiments. But it will not register this model as a new model unless you wanted to, but my implementation will not register it if the evaluation part, which is one of the steps we're having here, doesn't come with a good insights that the new model is better in terms of precision and recall. So the criteria here that you rely on to register your model, it's totally up to you. There differs to based on the data science success criteria for the model. Maybe some people say, okay, I want to focus more on the recall, and if the recall percentage passes this threshold, I will register the model anyway. So this is mainly based on the problem or the data science problem that you are trying to solve. The last step is, it's as simple as that you create the Docker image. So and again, it's not related to the build, but I added in the build definition. So this is simply a step where you can just take an image and create of your Docker container, because we will use this image when it comes to the model deployment. In my scenario, I'm deploying the model as a REST API. So I'm not doing any batch scoring here. I'm just using it as a REST. I'm just deploying the model as a REST API. So if we have a look on the create Docker image, you can see that I'm still using the SDK, and I'm using this container image .image configuration, and I give it my score file. So if you recall the deployment workflow that we mentioned, you need to give an example for scoring. So this is just a Python script that loads the model, give it an input, retrieve the outcome. It's as simple as that. And also I'm defining my runtime. I'm adding here my conda dependencies, which is in the configuration. I'm writing as some descriptions and tags. And you can see here in the ML configuration that I have the conda dependencies, which is mainly listing the required packages for the Azure Machine Learning execution. That includes the SDK, the SciPy, the Pandas, the NumPy with versions. So if we look back here, and again, it's a matter of just calling one method to configure this, and then another method to create the image, the Docker image itself. And if it's succeeded, we just load it to the Azure Container Registry. So if you see here, if we jump to here, to the visualization on the Azure portal, once this code runs, you can see your Docker image here as well listed with the image type as Docker and the state and the version and everything. And just to finish this pipeline before we move to the release pipeline. So till now, I didn't deploy the model. I'm just running an automated model under the build definition to create the workspace, run the training, do the evaluation. If I'm happy about my new model, my newly trained model, I will register it and I will create a Docker image. And I'm just here saying, okay, we produced some artifacts, right? And I want to save this artifacts under folder into the repo, because I will use this artifacts as a starting point for my release definition. So before moving to the release pipeline, and the release pipeline definitely contains different environments. There are dev and test environment, there are staging. Let's have a stop here just to have a second checkpoint for Q&A. And then we move to the release pipeline and see how we complement our current continuous delivery pipeline by having a release definition. Because if you recall, we had this list. We just covered how the backlog was constructed, what the data are using, how we do the data validation, the environment setup files, the trainings. We covered some of the CI practices, and we walked through all the steps for the build definition. After the second checkpoint, we will move the focus to the release definition and see how we are building this release pipeline to deploy our model to different environments. So let me just go.
We have a few questions from the community. So the latest was on using Azure DevOps with a model created in Azure ML Studio. So is that possible to be used?
Yes, so you can use the designer as well, and you in the designer you have a view for the Azure pipelines. So I think it's still in preview, so you can use this Azure pipelines in the designer to be able to create your end-to-end pipeline working with the designer and the UI part.
Also, another question from the community was on the ML engineer. Is he tasked to creating the files in the ML workspace folder?
Yes. So in most of the cases, that's the case. So it's different how the companies are addressing it. Based on my experience, I saw some companies that they hire someone called it machine learning engineer. They assign these kind of tasks to him. Some companies they have a DevOps engineer and they include this part under the responsibility of the DevOps engineer. But what we agree on, it's not the data scientist's responsibility to write the scripts or build the DevOps pipeline to be utilized here. The data scientist here is expected as the user of this DevOps pipeline.
Also, a question for the code that is written in DevOps, is it also viewable in AML UI in notebooks?
Yes, you can use notebooks. Here I'm using scripts, so I'm using, I wrote my code into Python files, but you can rely on scripts. One of the practices that we are doing in a current project is that data scientists are preferring to use Jupyter notebooks, and we constructed our DevOps pipeline to move these notebooks to Databricks clusters. So their compute targets is Databricks, and we move these notebooks to Databricks so that they can use it within the Databricks environment or the Databricks cluster. So yes, in just my current work through, I'm not using the notebooks, but definitely this is one of the options, and most of the people they use it with Databricks. At least in my, when I say most, in my experience with the projects I had.
Also, there was a question on Azure DevOps artifacts. Does it feed normally into the workflow of ML? And is that a good practice?
Sorry, I didn't get that. So can you just repeat? Sorry for this.
Is Azure DevOps artifacts feeds normally in the workflow of ML, and is it a good practice?
So you have, if I get this right, you have to when we move to the release definition, if you saw here in the pipeline we had in the build definition. So this is my build pipeline, and you will see that I'm already having a task for publishing these artifacts in the staging directory, which is under the name of drop. And when we move to the release definition, it doesn't normally come. You have to specify that the source of the stages is this drop folder. So if you see here in my artifacts, and I'm here moving to the release definition, you can see that I am specifying that I want to use the MLOps CI, which is the name of my build definition, and the artifacts are published in the drop folder. So you have to come here, add an artifact, and refer to the artifacts created from your build definition pipeline.
There were also a few requests on sharing some resources on GitHub for the community to go back to and use.
Sure. I'll make sure that. So I have some on my GitHub, so I will check the link within the IM. But I will make sure to generalize this pipelines and publish it as well on GitHub after the session to make sure that you can have access to these pipelines.
Yeah, I think that's pretty much it for the questions at this checkpoint.
Perfect. Thank you, Sam. So let's move, since we got like limited time. So let's move to the release pipeline. So the release pipeline, as I showed part of it in while answering the questions of the artifacts, is first of all, it's having these artifacts loaded, and also I'm enabling the continuous deployment, but on the level of the dev and test environment, which is this environment. But when it comes to the staging or production environment, I'm adding approvers as well. So I'm just adding myself here for an example, but normally people who are added here as approvers are release managers. So the dev and test is open. You can just have this continuous deployment. Once the build definition is done, up and running, you can just move to it. But The other environments are secured by gatekeepers. We call them release managers. And this is as simple as that, my release definition. Since this is a dev and test environment, I'm using Azure Container Instance because no need for high scale here. So for production, I'm using Azure Kubernetes Service, but for this one, I'm using the Azure Container Instance. And it's as simple as installing Python. Still, I need this to be done on my agent allocated from Azure DevOps, and you don't need to do it if you are assigning an agent as a virtual machine. So and instead of relying on the agent assigned to you from Azure DevOps, you can just link your virtual machine to Azure DevOps to be the agent that you want to use. And if it's that case and you already have Python installed on this virtual machine, you don't need to reinstall it. And you can see here I'm referring to Python script called deploy_ACI. So if we get back to this script, it's still a Python script that I'm executing using Azure CLI. And if we zoom here, it's as simple as that. First, it authenticates using the Azure CLI authentication just to authenticate to Azure, and it uses this ACI web service to deploy the configuration. So since we are provisioning an ACI instance, you want to define how many CPU cores, how many memories, memory GPU do you need, and then you deploy your model to be consumed as a REST API from the Docker image. So you pass the ACI configuration that you just created, you pass the Docker image that we loaded here at the beginning of the script based on from the workspace we created, because if you remember, it's all under the same workspace. So you can just filter your image using a specific image version and name, and you can search by tags as well. And then also you define name for your web service, and you define the workspace that you created. So the way you load the workspace is just by getting the workspace from configuration you needed. And that's the good thing, because you don't need actually to keep the secret credentials here. You just rely on the Azure CLI authentication, and it does the magic for the authentication, securing the authentication token. So if we move here to the release pipeline, let me just, okay, so this is one of the runs I did. So these are the steps, and I'm just showing the log of the step which is deploying on ACI. So what happens here is that it runs this script, the deploy_ACI.py. It uses the image, the Docker image that we created, using the image version that we defined. In the, if you see Azure CR, this is Azure Container Registry that we stored our Docker image at, and it replies back with the REST API URI. So if you call this URI and give it the right input for the model, you will receive the expected outcome of the model. So I created also here test file just to call this REST API. So this is the test API service. I give it an input, which is a record for a diabetic person or not, based on the model. The model decides, and it retrieves the results in terms of X and Y to classify the model based on the cluster. So the test script is simple as calling any REST API in Python. And if you want to track your deployments, you can come here in the deployment tab in the Azure Machine Learning Service workspace, and you'll find that you got a bunch of deployments. Let's say I want to use to check this one. You can also find the URL. Sorry, the scoring URI of your model here. So, and this is one of the features I do like about the Azure ML service, because deployment is painful process. So it's really good that you just rely on one method, giving it the right Docker image with the right configuration, and then boom, it replies back with the URI, where you can pass this URI, or you can use it, consume it also from Postman, for example, to test if you don't want to test it programmatically, and then expose this endpoint to the rest of your architecture. And yes, so I think we are on time. Yeah, I think we pretty much covered most of them. One of the things I wanted to highlight is that in this pipeline, I didn't store any credentials because of the fact that I'm relying big time on the Azure CLI authentication. But in other stuff, maybe, for example, you need to store some keys for Databricks. If you're using Databricks, you can use Azure Key Vault, and you can come here to the variables, sorry, in the library, and you can add a global variables here, and it allows you directly, if you see here, to link your secrets from Azure Key Vault. So if you created an Azure Key Vault on your Azure subscription that got your secrets, you can just link it directly to Azure DevOps without the need to expose these credentials in the pipeline for better security. Yeah, and I think by that we managed to cover the release pipeline. For AKS, it's kind of pretty much of the same. I just changed the resource I'm using. And if we move here, just for a quick overview to the Azure portal, you can have a look that it's already created the Azure Machine Learning Service. We have created the container instance. These are the resources provisioned when we run the pipeline. So after the session, I will publish this pipeline. You can just change the subscription ID and run the pipeline, and you will see these resources are being provisioned on your Azure subscription, and you can see this end-to-end pipeline running and the resources provisioned and the models created to have the feel of how the end-to-end scenario for your custom machine learning projects is done. And by that, I think we pretty much covered it all. Happy to answer your questions in the rest of the time.
Thank you, Sherif, for your valuable time and this great session. I'm sure everyone loved it. And yeah, we're here for another minute or so to answer any more questions that come from the community. I think everyone is keen to have access to the resources and to the GitHub repo. So we will share that in a comment in the description of or in the event page. So make sure you go on the Reactor Abu Dhabi page as well to join it if you are not yet a member. So I posted that in the Q&A as an announcement. You will find the link there, and we will put the resources right after the session. Also, the recording of this session will be available on the same link. So if you just join after we finish the live event, in case you joined later or like you missed some parts at the early stage, you can definitely watch it again and follow along using the resources as well. So it will be available on the same link. All right, I see a couple of questions coming in. So how the AKS setting looks for production pipeline?
Yes, let me just show it quickly. Yeah, so if you see here, we have in the release definition the other environment. And I'm just calling it staging. So as you see here, this time I'm deploying to AKS, and I'm using the same kind of way of doing it. So I refer to one of the scripts I have under the AML service. So if we look at the AKS part, which is deployed to AKS, it's pretty much the same because I'm still using the same SDK, and I'm just creating one cluster, but I check if AKS is already available. If available, I use it for deployment. That means this is not the first time that I run the script. If not, I just create it with basic configuration. So as we did with the ACI, you can still load the configuration you want, relying on the SDK just to load it from the configuration file. So I have a JSON file that I save the configuration of AKS that I need to have in this JSON file, and then I load it to configure the AKS using the SDK by just passing this configuration to the AKS to define the compute target, the AKS target, what would be the name of the AKS service, how many clusters, the pods, all of this configuration like typical Kubernetes configuration file. So the kind of the good practice here is just to isolate the configuration than the code, just to have it in a file, and from this file you load the configuration, pass it to the Azure ML service, and the Azure ML service will take it from there to provision your AKS.
All right, thank you, Sherif. I think that's it with the questions. Thank you so much for your valuable time, and we definitely need to plan more sessions for the community. Thank you, everyone, for joining us today on the stream as well and engaging with the questions. Make sure you join our meetup group if you haven't already, and make sure also you follow us on Twitter, MSFT Reactor, and the hashtag for Abu Dhabi is Reactor Abu Dhabi. Thank you, everyone, and see you in the coming sessions. Make sure you check out our calendar. We have a very busy month, and we'll see you in the next one.
Great. Thank you, everyone. Enjoyed. Bye-bye.
Bye-bye.